Hello everybody, we are going to be covering the 3-point notes today, which is proving triangles are congruent by hypotenuse leg. Whenever we talk about proving triangles are congruent by hypotenuse leg, this method is only going to work if you have a right triangle. So although we are adding this to our list of ways to prove congruency, just know that this can only work if we have a right triangle, okay? So right now we know 4 ways to prove congruency. We have side, side, side. We have side, angle, side. We have angle, side, angle. And we have angle, angle, side. So those are our 4 that we know. If you know the lengths of 2 sides and the measure of an angle that is not included between them, you can create 2 different triangles. Therefore, side-side angle is not a valid way to prove that triangles are congruent. However, there is a special case for right triangles, and we talked about that very briefly when we did our first day of proofs for side, 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 and side, angle, side. So the newest method that we have to prove congruency is called hypotenuse leg, HL. And this says if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the 2 triangles are congruent. Can the 2 triangles be proved congruent? If so, name the congruent triangles and give the reason. Okay, so when we look at number 1, we should notice that we have a right angle. You can still have all of the other ways to prove congruency when you have a right triangle, but now because we have a right triangle, we can add on that hypotenuse leg. So when I look at this, I clearly have a right triangle. If you look at the triangle itself, the hypotenuse is marked congruent and one of the other legs is marked congruent. It doesn't matter which of the other legs are marked congruent for it to be hypotenuse leg. So just keep that in mind. So we could say yes, these are congruent by hypotenuse leg. Triangle BAC, we start at B, move to A, move to C, will be congruent to triangle ZYX. Number 2, I'm being told that I have a right angle here. So I do know that I can add on my hypotenuse leg. If you look, because these are right triangles, my hypotenuse is marked congruent, and I can go ahead and, using that reflexive property, say that this leg over here for both of my right triangles is also congruent. So again, this is yes by hypotenuse leg. BAC will be congruent to triangle DAC. When you look at number 3 does not provide us with a right angle. So that means that I only have my 4 other options. My side, 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 angle, side, side, angle, and angle, angle, side. I cannot use hypotenuse leg on this one because it's not a right triangle. I do have an angle that's marked congruent. So if it is congruent, it would be for one of these 3 reasons. So I have an angle marked congruent and I have one side marked congruent. I need another piece of information and I have that reflexive property. Remember that when you do not have a right triangle, wherever your congruent sides come together, that intersection is where the angle should be. The angle is not in the appropriate place, so this is no, and this one is side-side angle, which is bad. Remember, it's a bad word spelled backwards, and because these are not congruent triangles, I cannot write a congruency statement. I'm going to go ahead and skip numbers 4, 5, and 6 because we've seen these examples before. I'll have them on the completed notes, but for this example here, or for what we're doing for this video here, I'm not going to worry about those 3. None of those 3 are right triangles, so none of them would be able to be proven congruent by hypotenuse leg. Okay. So we are going to be talking a lot about perpendicular lines today because we have to have right triangles in order for us to use hypotenuse leg to prove congruency. So anytime that you are given perpendicular lines, you must include 3 of the following steps. So notice that numbers 1 and 2, you have to do every time. And then for your 3rd step, you're either going to have option A or you're going to have option B. It just kind of depends on how we're proving congruency. So the first step is to mention your perpendicular lines. So we're going to mention our perpendicular lines. Once we have perpendicular lines, we automatically know that we have right angles. So now you're going to mention that you have right angles, okay? Earlier in our proofs, if we had right angles, then we would say, okay, well now your two right angles are congruent. So angle whatever is going to be congruent to angle whatever because all right angles are congruent. But now that we're adding in hypotenuse leg as a method to prove congruency, in order for us to use hypotenuse leg, we have to say within our proof that we have a right triangle. So that's what the second option for 3 is, 3B. Well, you need to mention that you have a right triangle. This is in your blueprint, wherever your perpendicular lines information is given to you. We just haven't had to use it yet because we haven't needed to mention right triangles. Now, the reason I have this marked the way that I do is because when you do a proof, we don't want any extra information in our proof. And as we first learn how to prove using hypotenuse leg, sometimes we don't know where we're going with our proof, which is why including both number 3s, 3A and 3B is important. But then once we complete our proof, then we're gonna have to go back and actually cross out one of our number 3s. Okay, so it says step 1 and 2 are always required when you're given perpendicular lines. So no matter what, you have to mention that you have perpendicular lines, and then you have to mention that you have right angles. You will only include step 3A if you are proving your triangles congruent by any other method other than hypotenuse leg. So for example, side's not going to matter because you need an angle for that, but I'm just going to mention it anyway. So side, angle, side, angle, and angle, side. So if I am proving my triangles are congruent by any method other than hypotenuse leg, I'm going to have that first number 3 option, 3A. If I end up proving my triangles are congruent by hypotenuse leg, then I do not need 3A, and instead I'm only going to need option 3B. So let's do an example so that you can see the difference of how this proof will look. So I'm going to start by writing down my givens. My first given is BD is perpendicular to AC. That was given to me. Remember that when I write down my proofs, my goal is to find congruent things, and so I'm looking for a congruency statement, which I do not have here. So if BD is perpendicular to AC, then based on my thing up here, my second step would be to mention that I have right angles. So I can say that angle 3 and angle 4 are right angles. That still does not give me congruency, so I know that I'm going to have to go one step further with this same given information. This is definition of perpendicular. Now that I know that they're right angles, I'm going to mention that angle 3 is congruent to angle 4. So that's an angle. But because I don't know how I'm ultimately going to prove that these triangles are congruent, whether it's hypotenuse leg or any of the other ones, I have to write down number 3 again. And I'm going to put a little or next to this. So either I'm going to need angle 3 is congruent to angle 4, or I'm going to need to mention that triangle ABD and triangle CBD are right triangles. So this first number 3 is going to be all right angles are congruent, and then my second number 3 is definition of right triangle. Okay, now that takes care of that given. So now I'm going to go down to my next given, which is that segment AB is congruent to segment CB. That was given, and that's a segment. Okay, so I've got AB being congruent to CB. I'm out of givens, so now I need to look and see if there's anything that I can say is true without a given. So that's, again, typically vertical angles or the reflexive property. And if you look up at your picture, you definitely have that reflexive property. So we've got DB is congruent to DB, and that is the reflexive prop. That is another segment that is congruent. So now I have enough information to prove congruency. Now, if you look at the order, it gives you the order as angle, side, side, which is not a way to prove congruency, but that's why the picture is more important than the order of your red circled letters. So at this point, I now have enough information to prove my triangles are congruent. So triangle ABD is congruent to triangle CBD. And if you look at your picture, you did that by side angle side. Because I did not use hypotenuse leg, I don't care that I have right triangles. So I need to go in here and mark out the second number 3. And then if you look at your numbered steps, notice that even though I marked out something, my steps are still in order and there's nothing missing. That's why it's important that we put number 3 twice, because that way when you like mark out one of your number 3s, nothing changes with the numbering of the steps. Okay, so we're gonna always have to mark out one of the number 3s. It just depends on if we need the right triangle for hypotenuse leg or if we need congruent angles for all of the other methods of congruency. Let's go down to this one right here. So I was given the same type of given here. BA is perpendicular to CA and CD is perpendicular to BD. I'm gonna go ahead and put those in the same line. So I've got 2 perpendicular things that are given. So BA is perpendicular to CA. That would mean that angle A is going to be a right angle. And then CD is perpendicular to BD, which means that angle D is going to be a right angle. That's going to be the definition of perpendicular. I still don't have anything congruent yet, so that's where my next step comes in. I'm going to say that angle A is congruent to angle D. My second option, remember, is that I need to mention that I have right triangles. And I just use whatever right triangle name they gave me there, or whatever triangle name they gave me there. Triangle ABC and triangle DCB are right triangles. Okay, so the first number 3 is all right angles are congruent. And then the second number 3 is, this is just the definition of right triangle. And then we're going to move on. Okay, I was given that AC is congruent to BD, and that was given. So I've got AC being congruent to BD. Okay, so that's a segment. Up here I had an angle, so I just need one more piece of information to prove congruency, but I'm out of given statements. So now I need to look at my picture and see if there's anything else that I can mention, and I have that beautiful reflexive property again. So BC is congruent to BC. And that is true because that is the reflexive prop. That is another segment. So when you look at your picture, you need to decide how these triangles are going to be congruent. So triangle ABC is congruent to triangle DCB. This is going to be hypotenuse leg. Because it is hypotenuse leg, I need my right triangle information. I do not need this angle information. Okay, now if you look at the circled red letters, notice that you have a side and a side. AC is going to be considered your leg, and BC is considered your hypotenuse. So that's your hypotenuse leg information. You don't have to go back and like remark it as such, but I'm just showing you what that's going to look like. All right, and that's all we have for hypotenuse leg. So nothing super different about this method of proving congruency, other than now you're going to have to mark out a piece of information as you do your proofs if you have any kind of perpendicular line, okay? But just follow the steps that I've given you here. It should help. And then I'm going to go back and do these 3 in the completed notes, but for now, that's all I have for you. If you have any questions on these notes, go ahead and go see your teacher during their normally scheduled tutorial times, and I will see you in the next video. Bye!